Imagine you're uh, commanding this highly specialized, like lightweight carbon fiber racing yacht.
Okay.
You've spent decades optimizing this specific vessel for speed, agility, and participating in very specific multinational regattas.
Right. Very niche.
Yeah, you've stripped away every single ounce of heavy armor. You rely entirely on other ships for your heavy logistics, and your crew is, well, they're trained specifically for navigating well-mapped, relatively calm summer waters.
Sounds idyllic.
It is. I mean, it's a masterpiece of specialized engineering for a very specific era. But then, midway across the ocean, the climate just plummets.
Oh, wow.
The water around you begins to freeze into this thick sea ice, and massive, heavily armed dreadnoughts start appearing on the horizon,
Yeah.
and they're actively ignoring all the international shipping lanes.
That's a terrifying mental image.
Right. You look at your little carbon fiber hull, and you realize with a cold sweat that you don't need a racing yacht anymore.
No, you definitely don't.
You need a heavily armored, self-sustaining icebreaker. And you need to figure out how to retrofit your ship while you're literally still sailing it.
Which is almost impossible.
Exactly. We've got an incredibly timely deep dive for you today, looking at a nation attempting exactly that kind of retrofit.
It's a moment of profound structural shock, really. Because when the architecture you meticulously built for one geopolitical era when it becomes an active vulnerability in the next, the required pivot is agonizingly difficult and, incredibly expensive.
Totally. So today we are mapping the massive generational transformation of Canada's military strategy, specifically zeroing in on its sudden multi-billion-dollar pivot back to heavy armor and next-generation tanks.
That's a huge shift.
To chart how a military goes from, a light expeditionary force back to preparing for high-intensity peer-on-peer conflict, we're pulling from a literal mountain of highly technical sources.
We really are. There's so much data here.
Yeah, we have the Canadian Army's newly published Inflection Point 2025 strategy document, a deeply concerning Parliamentary Budget Officer report on defense spending realities, and technical engineering analyses of modern battle tanks.
Plus those deep dives into international defense industrial policies.
Right, like the Grosswald report on Poland's massive armor procurement. And we're even synthesizing insights from military personnel actively debating the survivability of modern armor on Reddit.
Which is a fascinating cross-section of sources, honestly. It blends the highest levels of theoretical strategic policy with the brutal, grounded physics of what happens when a 60-ton piece of steel actually meets an explosive drone on the battlefield.
Yeah, the rubber really meets the road there.
Or the tracks, I guess.
Exactly. To really grasp the stakes here, we have to recognize that the global operating environment is, well, it's undergoing a moment of severe, undeniable strategic disruption.
Right.
The rules-based international order is under immense pressure from authoritarian states that are, willing to use industrial-scale violence to redraw borders. And at the same time, the physical character of warfare is changing.
Oh, absolutely. It's being actively reshaped by converging technologies like artificial intelligence, ubiquitous sensors, and even the shifting geography brought on by climate change.
Okay, let's unpack this shift in doctrine first. Because the equipment a military buys is ultimately just a physical manifestation of how it plans to fight.
Yeah, that's a great way to put it. Form follows function.
So for the last few decades, if you looked at Canada's military posture, it was explicitly optimized for what the doctrine calls contribution warfare.
Yeah, contribution warfare. It's a very specific political and military design. It essentially means generating smaller, highly specialized force packages.
Like light infantry and special ops.
Exactly. Light infantry, special operations teams, or training cadres. And you generate those to plug into larger multinational coalitions.
So it's not about going it alone.
Not at all. It's a strategy designed for peace support, capacity building, or counterinsurgency operations. Think of the deployments to Afghanistan or the peacekeeping missions in the Balkans and Somalia.
Right. You're not designing a force to win a war on its own?
No, you're designing a force to be a valuable, interoperable puzzle piece for NATO or the UN.
I would assume that strategy leaves some pretty massive gaps in your domestic capability, though. Like if you ever have to fight outside of that specific coalition context.
Oh, it leaves systemic vulnerabilities. I mean, when your primary adversaries are insurgents relying on asymmetric tactics,
Yeah.
you simply do not require the massive, heavy combined arms formations needed to fight a mechanized state actor.
So you just stop funding them.
Right. You divest from heavy, long-range, self-propelled artillery. You divest from layered ground-based air defense systems because, well, you assume coalition air superiority.
You assume the U.S. will handle the skies.
Yeah, exactly. And most importantly, you pare down the massive logistics tail required to sustain tens of thousands of troops in high-intensity combat. Over decades, those heavy capabilities atrophy, both in terms of the physical equipment and the institutional knowledge.
And structurally, reading through the strategy documents, this contribution model meant the Canadian Army organized itself around independent battle groups.
Yeah, the battle group. It's essentially a task-tailored unit built around an infantry battalion. It's usually reinforced with a squadron of armor and some localized artillery and engineer support.
How big are we talking?
It totals roughly 1,000 to 1,500 personnel. And they're highly effective, nimble formations for localized, low-intensity missions.
But not for the new era.
No. The core thesis of the Inflection Point 2025 document is this stark realization. In major combat operations, or MCO, against a peer adversary, an independent battle group simply lacks the mass, the integrated deep fires, and the endurance to survive.
It lacks the endurance on a modern, lethal battlefield. The strategy document is unusually blunt about this, actually. It states outright, the army we have is not the army we need.
Which is quite the admission.
Yeah. It sounds like a neighborhood watch program suddenly realizing they need to become a fully self-sustaining SWAT team.
Wow, that's actually a very accurate analogy.
So if a battle group is insufficient for the new threat landscape, what is the structure they're frantically trying to build?
The shift they're outlining is moving away from generating those localized battle groups and toward generating modern warfighting systems at the division level.
A whole division.
Right. A maneuver division is a massive, incredibly complex formation of roughly 15,000 soldiers.
Wow, 15,000.
And it's not just about having more infantry, it's about having organic depth. A division has its own dedicated air defense regiments, its own long-range strike artillery, massive engineering elements to bridge rivers and clear minefields.
It's like a self-contained city moving into combat.
It really is. And crucially, it has this staggering logistical apparatus that can push fuel, ammunition, and medical support forward under continuous enemy fire.
But why now? I mean, if you're an observer of NATO dynamics, the immediate question is why Canada feels the sudden urge to shoulder this specific burden. Historically, hasn't the strategy been to let larger allies, specifically the United States, provide that massive heavy armor umbrella?
That assumption has literally been the bedrock of Western Allied planning since the end of the Cold War. But the new Canadian strategy explicitly defines a terrifying new metric. They call it the lethality gap.
The lethality gap.
Yeah. The document acknowledges that Canada can no longer safely assume that allies will just magically provide critical combat enablers like ground-based air defense or heavy armor.
Because the allies themselves divested from those exact same capabilities during the counterinsurgency era.
Precisely. The peace dividend was cashed in by almost everyone. If we connect this to the bigger picture, the Russian invasion of Ukraine fundamentally shattered the prevailing Western illusion that conventional state-on-state warfare at a massive scale was a relic of the 20th century.
Yeah, that illusion is definitely gone.
We are watching artillery duels consuming thousands of shells a day and mechanized engagements on a scale not seen since the Second World War. The lethal lesson being written in Ukraine right now is that if a military waits until a conflict actually breaks out to scale up its division-level capabilities, it has already lost.
It's too late by then.
Exactly. Building a 15,000-person mechanized division, training the commanders to orchestrate it, and procuring the heavy armor to protect it, that's a multi-decade endeavor.
Let's transition from the theoretical doctrine to the physical hardware that actually exists right now to execute this division-level warfare. If tanks are the indispensable anchor of a heavy maneuver division, we have to look closely at the physical armor Canada possesses today.
It's a bit of a sobering look.
Yeah, looking at the inventory breakdown in the sources, it paints a picture of a fleet that is not only small but incredibly fragmented.
Right. The current Canadian heavy armor fleet consists entirely of Leopard 2 main battle tanks, which were originally manufactured in Germany.
Okay.
And according to the defense sources, the total inventory sits at 103 vehicles. But as you noted, that number is highly deceptive. It is not a uniform fleet of top-tier fighting vehicles.
Let's break down those variants because the technical differences really highlight the strain on the system. The sources show 34 of those tanks are older Leopard 2A4 variants.
Yeah, so the 2A4 is essentially late Cold War technology. While it's still a capable machine, these specific hulls are roughly 3 decades old.
3 decades, wow.
The military uses them primarily for domestic training, but they are struggling with severe spare parts obsolescence. I mean, suppliers simply aren't making some of the legacy components anymore, meaning keeping them operational is just a constant logistical battle.
Then the documentation points to 20 upgraded Leopard 2A4M cans. I assume the M denotes a modernization effort specific to Canadian requirements.
Yes. The 2A4M cans were heavily modified based on the brutal lessons learned in Afghanistan. The primary upgrades were significant additions of modular composite armor and enhanced belly protection.
That was to survive massive improvised explosive devices, right?
Exactly. IEDs were the primary threat, and those upgraded tanks currently form a significant portion of the deployable heavy force.
But the crown jewels of the current fleet seem to be the 20 Leopard 2A6M cans. The engineering specs highlight a very specific change to the main armament on these models.
Yeah, the defining feature of the 2A6 variant is the integration of the Rheinmetall L55 120mm smoothbore gun. The older tanks use the L44 gun.
What does that extra barrel length actually accomplish in terms of physics on the battlefield?
Well, it comes down to internal ballistics and kinetic energy. The 55 means the barrel length is 55 times the diameter of the 120mm bore.
Oh, I see.
So by lengthening the barrel by over a meter compared to the older gun, the expanding propellant gases from the fired cartridge have more time and distance to accelerate the projectile before it exits the muzzle.
Which means it's flying faster.
Significantly higher muzzle velocity, yes. And when you're firing armor-piercing, fin-stabilized, discarding sabot rounds, which are essentially massive, dense metal darts relying purely on kinetic energy to punch through enemy armor, that extra velocity translates directly into greater effective range.
And much deeper penetration against advanced enemy tanks.
Exactly.
So out of the 103, we have roughly 40 highly capable combat variants split between 2 different modernization standards, plus the 34 aging training models. And the remainder of that 103 number aren't even tanks with turrets, are they?
No, they aren't. The remaining vehicles are specialized engineering assets built onto the Leopard 2 chassis. And honestly, an armored division cannot move without these.
What kind of assets?
The inventory includes 18 Wisent 2 armored engineering vehicles. These are heavily armored tractors designed to push through physical barricades, fill anti-tank ditches, and plow through minefields under direct fire. And there are also 11 armored recovery vehicles.
Which are essentially the world's most heavily armored tow trucks.
Essentially, yeah. If a 60-ton tank throws a track in the mud or takes a mobility kill from a drone, you can't just leave it there.
Right, you need something just as big to move it.
Exactly. You need a vehicle with equivalent horsepower, armor, and massive winches to drag it off the battlefield for repair.
Adding to this numerical strain, we have to factor in the geopolitical decisions of the last 2 years. Canada donated 8 combat-capable Leopard 2s, along with a recovery vehicle, directly to the armed forces of Ukraine in 2023.
Yeah, and while that donation provided critical, immediate support to a vital ally actively fighting a peer adversary, it mathematically exacerbated an already critical domestic shortage.
It's a tough balancing act.
It really is. When you take the total fleet, subtract the vehicles permanently down for heavy maintenance, subtract the ones required for domestic crew training, and subtract the forward-deployed tank squadrons serving in Eastern Europe as part of NATO's deterrence mission.
What are you left with?
The actual number of ready-to-fight tanks held in reserve in Canada drops to a worryingly fragile number.
Digging into the historical reporting in our sources, there's a staggering institutional pivot that happened roughly 20 years ago. In October 2003, the Canadian Army commander at the time, Lieutenant General Rick Hillier, held a press conference where he explicitly announced his intention to scrap the Leopard tank fleet entirely.
Oh yeah, it remains one of the most debated doctrinal moments in modern Canadian military history.
The sources quote him calling the heavy tanks a millstone around the neck of the military. His vision was to replace them completely with the U.S.-manufactured Stryker mobile gun system, which is an 8-wheeled armored vehicle mounting a 105mm gun.
That was the plan.
He was heavily influenced by the idea that heavy tracked armor was a relic and that the future belonged to fast, highly deployable wheeled systems. But look at the strategy today. Tracked heavy armor is considered the absolute centerpiece of the new maneuver division. It seems like a massive doctrinal whiplash.
It really does. And it's easy to view that 2003 decision through the lens of hindsight, but we must analyze the prevailing military theory of that specific era.
What were they thinking back then?
The early 2000s were dominated by a concept called the revolution in military affairs. The assumption was that advanced sensors, precision-guided munitions, and overwhelming air power would render heavily armored, slower-moving ground forces obsolete.
The whole "we'll just bomb them from the sky" mentality.
Right. Furthermore, the operational reality of the 1990s was defined by peacekeeping missions in the Balkans or Somalia. In those scenarios, strategic mobility, like the ability to quickly fly a vehicle into a theater on a C-130 transport plane, was prioritized over heavy armor protection.
So if your entire threat matrix is based on fighting lightly armed militias in urban environments, a 60-ton tank that requires massive transport infrastructure seems like a logistical anchor.
That was exactly the logic. But the brutal reality of ground combat in Afghanistan forced a rapid recalibration.
Reality hit back.
It did. Canada quickly learned that when infantry are pinned down by heavily fortified insurgent positions, wheeled vehicles with thinner armor and smaller guns simply cannot provide the necessary shock effect and direct, overwhelming firepower.
So they had to go back to tanks.
Yeah, they had to rush to lease and eventually buy the Leopard 2s we have today because the older Leopard 1s were proving highly vulnerable. The lesson learned was that there's no technological substitute for the localized protected firepower of a main battle tank.
Which presents a severe temporal problem for the Army today. If the strategy demands a heavily armored division, but the current fleet is stretched to the breaking point and facing obsolescence, how do they bridge the gap between today and the eventual procurement of a next-generation tank fleet in the 2030s?
That's where the interim upgrade comes in. The sources detail a program called the Heavy Direct Fire Modernization Project, or HDFM.
Yeah, a $620 million stopgap measure.
Specifically targeting those 20 Leopard 2A6M tanks to keep them viable on a modern, digitized battlefield until a replacement can be fielded.
The engineering documents describe this as more than just a mechanical overhaul, though. It reads like they are attempting to perform a complete digital brain transplant on these platforms.
That is a very accurate assessment. The core of the HDFM is ripping out legacy analog architecture and installing a modern digital backbone.
Because in modern tank warfare, seeing the enemy first is everything.
It's the primary determinant of survival. So the upgrade includes installing third-generation thermal imaging sights for both the gunner and the tank commander.
And those sights are incredible now.
Oh, they detect minute temperature differences, allowing the crew to identify enemy vehicles through heavy fog, battlefield smoke, or complete darkness at ranges far exceeding the older technology.
Beyond just seeing better, the sources talk about networked fire control systems. I imagine this ties back into the division-level concept we discussed earlier, where a tank can't just be an isolated brawler anymore.
Absolutely. The HDFM integrates digitized turret drives and heavily encrypted, high-bandwidth communication systems. This allows the tank to plug into a broader digital network.
So they're talking to each other constantly?
Exactly. If a forward-deployed reconnaissance drone spots an enemy formation, that targeting data can be instantly beamed directly into the Leopard 2's fire control computer. That allows the tank to pre-align its turret before it even breaks cover.
That's wild. However, the defense policy updates are explicit that the HDFM is purely an interim life extension. Even with state-of-the-art thermal optics and digital communications, the underlying physical chassis of the Leopard 2 design is approaching 50 years old.
The metal can only take so much.
Right. The material science of the base armor and the mechanical limits of the suspension have largely been maxed out. The military has set a hard deadline for the retirement of the older variants by 2035, meaning the bureaucratic machinery must start moving immediately to secure a replacement.
And defining the requirements for that massive replacement program requires looking at where Canada actually expects to deploy this equipment.
It's not just Europe anymore.
No, it's not just about projecting power into Eastern Europe. The procurement is heavily, almost overwhelmingly dictated by the rapidly changing geography within Canada's own borders.
The recent defense policy update is tellingly titled, "Our North, Strong and Free." It is a clear signal that the Arctic is no longer viewed as a frozen, impenetrable shield.
The strategic calculus of the high north is literally being rewritten by thermodynamics. Climate change is physically altering the geography of the Arctic at an alarming rate.
The ice is disappearing.
As the multi-year sea ice melts, previously unnavigable waterways are opening up.
which immediately transforms the region from a geographic barrier into a highly coveted strategic transit route and a resource-rich frontier.
The geopolitical reaction has been swift, to say the least. Russia has spent the last decade heavily remilitarizing its Arctic coastline, refurbishing Cold War-era bases, deploying advanced S-400 air defense batteries, and expanding its fleet of nuclear-powered icebreakers.
And China's up there too.
Yeah, China has self-declared as a near-Arctic state and is increasingly active in the region with scientific and commercial vessels that often have dual-use military applications.
So for Canada, asserting sovereignty over this vast, remote archipelago requires far more than diplomatic declarations.
It requires a persistent, credible, and physically capable military presence capable of operating in one of the most hostile environments on Earth.
To build that presence, the policy documents outline an accelerated procurement of 250 tracked armored fighting vehicles, or AFVs, designed specifically to equip new medium cavalry battalions. And the urgency is palpable. They push the delivery timeline forward from 2035 down to the 2029 to 2031 window.
They know they're behind the curve.
But looking at the technical requirements for these vehicles, the baseline survivability metrics are astonishing. The documents demand STANAG Level 6 blast and ballistic protection.
STANAG is the NATO standardization agreement, which creates universal benchmarks for equipment performance. And Level 6 is an incredibly demanding threshold for survivability.
I want to break down what Level 6 actually means in terms of applied physics on the battlefield, because we aren't talking about stopping rifle bullets here.
Not at all. Ballistically, STANAG Level 6 requires the vehicle's frontal armor to completely stop a 30mm armor-piercing, fin-stabilized, discarding sabot round fired from a distance of just 500 meters.
Which is basically point blank for a tank gun.
Right, and this is the type of heavy autocannon ammunition fired by modern Russian infantry fighting vehicles like the BMP-3.
And the blast protection metrics seem even more extreme.
The blast requirement states that the crew inside the vehicle must survive the detonation of a massive 155mm high-explosive artillery shell, detonating a mere 10 meters away from the hull.
10 meters. That requires immense structural engineering. I mean, an artillery shell of that size produces a devastating overpressure wave and a storm of supersonic razor-sharp shrapnel.
It's a massive explosion.
To survive that at 10 meters means the vehicle needs highly advanced spall liners. Those are layers of Kevlar-like material inside the steel hull designed to catch any metal fragments that get knocked loose from the inside of the armor by the sheer kinetic shock of the blast.
Exactly. It requires thick, heavy composite armor, which inherently means a very heavy vehicle. But this creates a massive engineering contradiction when you look at the second major requirement for these Arctic vehicles.
Tactical mobility.
Right, tactical mobility.
This leads to a fascinating debate evident in the procurement documents. Canada currently operates the LAV 6.0, which is an exceptional, heavily armored, 8-wheeled vehicle. It has been highly successful in various deployments. So why is there a strict, non-negotiable requirement that these new Arctic vehicles must be tracked? Why not just buy more wheeled LAVs?
It all comes down to the brutal physics of operating in the Canadian North, specifically a concept known as mean ground pressure.
Let's explore the mechanics of ground pressure.
It's a relatively simple calculation. You take the total combat weight of the vehicle and divide it by the total surface area of the vehicle that is actually in physical contact with the ground.
Makes sense.
So if you take a highly armored, heavy vehicle and put it on 8 tires, the surface area touching the ground is relatively small. Therefore, the mean ground pressure is extremely high.
It's the classic analogy of someone wearing heavy boots versus someone wearing stiletto heels in a muddy field.
Exactly.
The person in heels might weigh less overall, but because all that weight is concentrated on tiny points, they punch right through the surface crust and sink into the mud.
That is the exact dynamic. In the Arctic, off-road terrain consists of deep snow drifts, partially thawed permafrost, and vast expanses of muskeg.
Muskeg is essentially a bottomless, waterlogged peat bog, right?
Yes, it's a nightmare for vehicles. If a heavy-wheeled vehicle attempts to traverse muskeg, its high ground pressure will cause the tires to instantly break through the surface tension. It'll sink the vehicle to its axles and immobilize it.
And tracks fix that.
Tank tracks are essentially continuous metal roads that the vehicle lays down for itself. They distribute the massive weight of the 50-ton or 60-ton vehicle over a vastly larger surface area. This low ground pressure allows a heavy tracked vehicle to literally float over soft snow and muskeg that would swallow a wheeled vehicle whole.
So the geography demands tracks, but the climate demands an entirely different set of engineering solutions. The engineering analyses frequently mention the necessity of extreme winterization. We are talking about operating machinery in temperatures that plunge to -40 or -50 degrees Celsius.
The extreme cold introduces catastrophic points of failure that simply do not exist in temperate climates.
Like what?
Well, the most basic mechanical challenge is fuel. Standard military diesel fuel begins to gel, and the paraffin wax inside it crystallizes at extreme sub-zero temperatures. This clogs the fuel filters and starves the engine. Therefore, any vehicle operating in the Arctic requires sophisticated, internally heated fuel lines and block heaters just to turn the engine over.
I would imagine the challenges extend far beyond just the internal combustion engine. I mean, modern armored vehicles are highly digitized. How do sensitive electronics handle -40 degrees?
Poorly, unless specifically engineered for it. Recent testing by Allied forces in extreme cold environments has revealed significant vulnerabilities in commercial off-the-shelf electronics.
They just break down.
Yeah. Liquid crystal displays on digital touchscreens freeze and become unresponsive. Lubricants inside the motorized turret drives freeze solid, preventing the gun from traversing.
That's a big problem for a tank.
A huge problem. The chemical reactions inside standard lithium-ion batteries slow to a crawl, causing massive voltage drops that can shut down the vehicle's entire sensor suite. Furthermore, extreme cold causes metal to contract and become brittle.
So the armor actually gets weaker.
Yes, meaning rubber gaskets fail. And physical impacts that the armor would normally absorb can cause catastrophic cracking.
It fundamentally rewrites the procurement evaluation. A tank might have the most advanced fire control system in the world, but if its thermal sights frost over internally and its digital communications array shuts down because the battery froze, it is effectively a multi-million-dollar paperweight in the high north.
Which is why the environmental testing phase for these next-generation vehicles will be just as rigorous, if not more so, than the ballistic survivability testing.
So the Arctic dictates the physical mechanics of how the vehicle moves and operates. But the reality of the modern battlefield, heavily informed by the ongoing conflict in Ukraine, dictates how the vehicle actually survives enemy contact.
Right. The threat landscape has changed completely.
And looking at our sources, specifically the media analysis and the intense debates on the military subreddits, we have to address the fundamental question of survivability in the drone era.
The proliferation of uncrewed aerial systems, specifically cheap, commercially available drones weaponized with anti-tank munitions, has undeniably altered the tactical calculus of armored warfare.
One of the CVC headlines in our source materials frames it bluntly, suggesting that drones are completely upending tank warfare. And if you read through the Reddit threads from military personnel and analysts, the skepticism is loud.
It's a very common talking point right now.
They are watching open-source videos of a $500 first-person view drone, piloted by a soldier wearing VR goggles miles away, dropping an older RPG warhead directly onto the roof of a $10 million main battle tank and causing a catastrophic ammunition detonation.
It's a stark contrast in cost.
The prevailing question being asked is, why are militaries continuing to invest hundreds of billions of dollars into massive heavy tanks if they are so easily destroyed by cheap, asymmetric technology?
It is a vital strategic question, and the visual evidence is deeply compelling. The modern battlefield has become incredibly transparent.
You can't hide anymore.
Exactly. Between high-resolution commercial satellite imagery, persistent high-altitude surveillance drones, and swarms of low-flying FPV drones, hiding the massive thermal signature and physical footprint of a 60-ton tank is almost impossible.
And those drones exploit the tank's weak spots.
Furthermore, these drones exploit the traditional design vulnerability of heavy armor. Historically, tanks are designed to face other tanks, meaning the thickest, heaviest composite armor is concentrated on the front of the hull and the face of the turret.
And the roof is thin.
Right. The armor on the roof of the turret and over the engine deck in the rear is significantly thinner. Loitering munitions and FPV drones are designed to execute top attack profiles, plunging vertically to strike where the tank is weakest.
Here's where it gets really interesting, though, because if I'm reading the Army's strategic doctrine correctly, they are vehemently rejecting the narrative that the tank is obsolete. The Inflection Point 2025 document implies that abandoning heavy armor because of drones would be a fatal error.
Yes. The military doctrine remains clear. There is absolutely no current technological substitute for the direct, protected, and highly mobile firepower of a main battle tank.
You can't just send infantry on their own.
Definitely not. If a commander orders an infantry company to assault a fortified, entrenched enemy position without the shock effect, the psychological terror, and the ability of heavy armor to instantly vaporize hardened bunkers with 120mm high explosive rounds, that assault will likely fail with catastrophic casualties.
The tank is still the spearhead.
The tank remains the decisive arm of maneuver warfare.
So we are left with a paradox. The tank is absolutely essential for offensive operations, but the airspace above the tank is saturated with lethal, cheap precision munitions. How does the military intend to solve this survivability equation for the next generation platforms?
The solution represents a fundamental shift in how we conceptualize vehicle protection.
Okay.
For the last century, survivability meant bolting thicker, heavier plates of steel and composite materials onto the hull. We have reached the physical limit of that approach.
Because they're just getting too heavy.
Exactly. Tanks simply cannot get any heavier without destroying the roads and bridges they need to cross. So the future of survivability relies on intercepting the threat before it ever touches the armor.
Intercepting it in midair.
Yes. This requires the mandatory integration of active protection systems, or APS.
Let's dive deep into the mechanics of APS because the engineering behind it sounds almost theoretical. The sources specifically highlight hard-kill systems like the Israeli-designed Trophy or the Iron Fist. How do these systems physically intercept an incoming missile traveling at hundreds of meters per second?
It relies on incredible computational speed and miniaturized sensor networks. Imagine a suite of small, highly advanced Doppler radar panels integrated flush into the corners of the tank's turret, providing a continuous 360-degree three-dimensional surveillance bubble around the vehicle.
So the tank is constantly radiating radar energy, scanning its immediate surroundings.
Constantly. And the millisecond one of those radar panels detects an incoming anomaly. Whether it's a supersonic anti-tank guided missile or a slow-moving FPV drone diving from above, the APS computer takes over.
What does the computer do?
It classifies the threat, calculates its exact velocity, and plots its precise intercept trajectory toward the tank.
All of this happens in fractions of a second.
We are talking milliseconds. Once the computer determines the threat will hit the tank, it triggers a countermeasure. The system relies on small, explosively formed penetrators or fragmentation charges mounted in launchers on the turret roof.
And it shoots back.
The system rapidly slews the launcher to face the incoming threat and fires a focused shotgun blast of dense metal shrapnel.
So the goal isn't to necessarily destroy the incoming missile completely, but to physically disrupt it.
Exactly. The kinetic impact of the shrapnel is designed to either detonate the missile's warhead prematurely in midair, away from the hull, or physically shatter the incoming projectile so that only harmless fragments impact the tank's base armor.
While that technology is remarkable, reading the tactical analyses suggests that hard-kill APS creates its own set of lethal complications on the battlefield, particularly for the infantry operating alongside the tanks.
That is the critical drawback.
Yeah.
If a tank is surrounded by friendly infantry using it for cover, and the ATS suddenly fires a high-velocity fragmentation charge to intercept a missile 10 meters away, the resulting shrapnel and blast wave from both the interceptor and the detonated missile can be lethal to the dismounted troops.
So you can't stand near the tank anymore.
Operating alongside APS-equipped armor requires entirely new tactical spacing and infantry coordination.
And further complicating the drone threat is the reality of swarm tactics. If an adversary launches 5 FPV drones simultaneously from different vectors, the hard-kill APS might intercept the first 3, but simply run out of ready ammunition to stop the final 2.
Which is why hard-kill APS is only one layer of the survivability onion. The defense analyses stress that next-generation tanks must also be deeply integrated with counter-uncrewed aerial systems, or CUAS, and heavily rely on electronic warfare.
I want to focus on that electronic warfare aspect. How does an armored vehicle use invisible spectrums to defend itself?
It requires projecting a localized electronic warfare dome around the armored formation. These EW systems constantly scan for the specific radio frequencies used by adversary drone operators to control their loitering munitions, as well as the GPS signals those drones use to navigate.
And when it finds them?
Once those frequencies are detected, the EW system broadcasts massive amounts of electromagnetic noise on those exact same channels.
Essentially screaming over the radio waves so the drone can't hear its operator's commands.
Precisely. The goal is to sever the command link, causing the drone to either crash harmlessly, enter a holding pattern, or lose its target lock before it ever gets close enough to trigger the tank's hard-kill APS.
Synthesizing all of this, the next-generation main battle tank is fundamentally evolving. It is no longer just a heavily armored bunker with a massive cannon.
It is becoming an immensely complex rolling sensor node. It must actively manage its own 360-degree radar emissions, coordinate electronic warfare jamming spectrums, process high-bandwidth digital communications from off-board sensors, and manage autonomous kinetic defense systems, all while navigating contested terrain.
That's a lot to ask of one vehicle.
It must function as a critical node in a multi-domain kill web, and its survival depends entirely on its ability to process electronic information faster than the adversary.
Knowing these monumental engineering requirements, the absolute necessity for track-based Arctic mobility with low ground pressure, the mandatory integration of complex hard-kill active protection and electronic warfare suites, and the overarching need to deliver overwhelming division-level lethality, the multi-billion-dollar question becomes, who is actually going to manufacture Canada's next-generation tank for the 2030s? Let's analyze the next-gen tank showdown outlined in the procurement documents.
Based on the strategic requirements, the timeline, and the global defense industrial base, the sources strongly indicate a likely three-way competition for the Canadian procurement.
Let's thoroughly examine the contenders, starting with the European heavyweight, the Leopard 2A8 from Germany.
The Leopard 2A8 represents the evolutionary institutional choice. It is the absolute pinnacle of a highly mature design. It weighs in at roughly 67 tons.
And it comes with the APS built in, right?
Yes. The defining advantage of the 2A8 is that it natively integrates the Israeli Trophy Active Protection System directly into the turret design from the factory floor, rather than bolting it on as an awkward aftermarket addition.
And from a strategic perspective, the strongest argument for the Leopard is likely interoperability with the rest of the alliance.
Interoperability is a massive logistical multiplier. The Canadian Army already possesses deep institutional knowledge of how to maintain, supply, and fight the Leopard platform.
Because we already use the older ones.
Exactly. Furthermore, almost all of our key European NATO allies, Germany, the Netherlands, Norway, Sweden, operate Leopard variants. In a major European conflict, if a Canadian tank suffers a major mechanical failure, a German logistics battalion likely has the exact spare parts, specialized tools, and trained mechanics required to fix it, and they can seamlessly share 120mm ammunition stockpiles.
However, the defense industry analyses highlight a significant bottleneck regarding the German option. It isn't an issue with the technology, but rather the bureaucracy of production.
The German Defense Industrial Base, and specifically the Government Procurement Office, has historically struggled with agility and production capacity. Ramping up heavy manufacturing lines takes years.
And everyone wants a Leopard right now.
With numerous European nations suddenly rushing to replace the Leopards they donated to Ukraine, the backlog for new 2A8 orders is severe. If Canada requires swift delivery to meet that 2030 deadline, the German production lines might simply not have the capacity to deliver on time.
Which brings us to the second contender. The undisputed heavyweight of the American arsenal, the M1A2 SEPv3 Abrams.
The Abrams is, without question, one of the most thoroughly combat-tested and technologically overwhelming machines ever designed.
It's a beast.
The SEPv3 variant features arguably the most advanced high-resolution sensor and networked targeting suite in the world, and geopolitically, purchasing a major U.S. weapon system guarantees flawless, frictionless integration with our closest and most vital military ally.
But the engineering specs reveal two massive, potentially disqualifying hurdles for the Abrams when we view it through the lens of Canadian requirements. The first is the sheer physical mass of the vehicle.
The SEPv3 tips the scales at a staggering 73 tons.
That weight has severe cascading effects across the entire military infrastructure.
It tests the absolute physical limits of Canadian logistical capability. Moving a 73-ton vehicle requires specialized heavy equipment transporters, reinforced rail cars, and bridges capable of supporting that concentrated load.
Not to mention the ground pressure issue we talked about.
More critically, referring back to our discussion on mean ground pressure, that extreme weight significantly degrades the vehicle's tactical mobility in soft Arctic snow or muskeg compared to lighter platforms.
The second major hurdle involves the engine architecture. Almost every modern tank in the world relies on massive, turbocharged diesel engines. The Abrams went a completely different route.
The Abrams is powered by a Honeywell AGT 1500 gas turbine engine,
Which is fundamentally the same technology that powers a commercial jetliner or a helicopter.
The advantage of a gas turbine is its incredible power-to-weight ratio and its ability to accelerate a 73-ton vehicle with surprising speed.
But the downside?
The severe drawback is fuel consumption. A gas turbine engine drinks jet fuel at an astronomical rate, even when simply idling to power the electronic sensors. The logistical tail required to keep an Abrams battalion fueled in the vast, remote, infrastructure-poor expanse of the Canadian North would be a monumental, continuous vulnerability.
Which leads us to the third candidate, a platform that seems to be aggressively disrupting the traditional Western defense market, the K2 Black Panther, designed and manufactured in South Korea.
The K2 is a fascinating divergence in tank design philosophy. Compared to the massive Western main battle tanks, the K2 is significantly lighter, sitting at roughly 55 tons.
That 15 to 18-ton weight reduction compared to the Abrams or Leopard seems directly applicable to the Arctic ground pressure problem we discussed earlier.
It fundamentally changes the mobility calculus in soft terrain. Furthermore, the K2 utilizes a highly advanced in-arm hydropneumatic suspension system.
Let's explain how that suspension system physically alters how the tank fights.
Unlike traditional torsion bar suspensions, the K2 system allows the crew to dynamically control the pressure in each individual road wheel. This means the tank can physically alter its stance.
Like it can crouch.
It can kneel down, lowering its overall profile to hide effectively behind a reverse slope or a ridgeline in a hull-down position. Alternatively, it can lean its hull forward or backward to significantly increase the depression or elevation angle of its main gun, allowing it to engage targets deep in valleys or high on mountain ridges, a crucial advantage in highly uneven terrain.
Another major divergence from the Abrams or the Leopard is the crew size. The K2 operates with a 3-person crew instead of 4 because it utilizes an autoloader for the main gun.
Yes, the K2 employs a bustle-mounted mechanical autoloader. This removes the need for a human loader to physically heave heavy 120mm shells into the breech,
Which saves space and weight.
This allows for a consistently high rate of fire, even while traversing rough terrain that would throw a human loader off balance, and reduces the overall personnel requirement for the Armored Corps.
However, the debate in the armored community often points out that an autoloader removes a crucial human element when it comes to maintaining the vehicle or dealing with mechanical jams under fire.
That is the trade-off. A 4th crew member is invaluable for pulling security during maintenance, reloading ammunition stockpiles, or clearing a jammed breach.
So what's the biggest selling point for the K2?
Perhaps the most compelling argument for the K2 isn't its suspension or its autoloader, it is the sheer industrial might behind it. South Korea has demonstrated a staggering ability to manufacture high-quality, heavy armor and deliver it at speeds that European manufacturers currently cannot match.
This speed of delivery seems to be shifting the entire center of gravity in global defense procurement. Are we witnessing a permanent realignment of the defense industrial base away from traditional Western European suppliers toward Asia?
What's fascinating here is, to understand the massive impact of South Korean manufacturing, we have to deeply analyze the Grosswald report detailing Poland's recent armor surge. Poland's strategy provides a profound case study for Canada.
Let's examine the geopolitical pressures driving Poland. They aren't preparing for theoretical future conflicts. They share direct borders with Ukraine, Belarus, and the highly militarized Russian exclave of Kaliningrad.
The Polish government looked at the invasion of Ukraine and determined they could not afford to wait a decade for European procurement bureaucracies to spin up. They initiated a procurement program of historical proportions.
How big are we talking?
By 2030, Poland intends to field roughly 900 next-generation main battle tanks.
To put that 900 number in context for the listener, that single procurement order will give Poland more active main battle tanks than the combined fleets of France, Germany, and the United Kingdom. It is a total militarization of their eastern flank. And to achieve those numbers, they heavily contracted with South Korea for the K2.
They chose the K2 primarily because of industrial speed and unprecedented technology transfer. Hyundai Rotem, the South Korean manufacturer, delivered the first batch of K2s, the off-the-shelf gap filler variants, in a matter of months, not years.
But Poland didn't just buy tanks, they bought the factory.
That is the crucial element of the deal. Hyundai Rotem agreed to deep technology transfer, allowing Poland to establish sovereign manufacturing capabilities. They are actively tooling massive factories in Gliwice, Poland, to domestically produce the K2PL variant.
The PL variant being specific to them.
This version is heavily customized for Polish requirements, featuring reinforced side armor and native active protection systems. Poland gets their tanks rapidly, but they also build a robust, localized industrial base capable of maintaining and eventually upgrading the fleet independent of foreign supply chains.
Contrast that aggressive tech transfer approach with the recent tank procurement competition in Norway, which the sources also detail. Norway ran a rigorous head-to-head evaluation between the German Leopard 2A7 and the Korean K2 in extreme winter conditions.
The Norwegian trials were highly anticipated because they perfectly mirrored the environmental challenges Canada faces. Interestingly, after the exhaustive physical testing, the chief of the Norwegian Armed Forces actually recommended purchasing the K2, citing its performance metrics, its rapid delivery schedule, and its cost-effectiveness.
Yet the Norwegian government ultimately overruled the military recommendation and purchased the Leopard 2. Why ignore the results of your own physical trials?
Because defense procurement at this scale is never purely about the ballistic specifications or the horsepower. The political leadership intervened to prioritize strategic geopolitics.
They chose their neighbors over the specs.
Norway decided that maintaining deep industrial and political alignment with Germany and ensuring identical logistical interoperability with their immediate Nordic neighbors, Sweden and Finland, who both operate Leopards, was more valuable than the slight technical or scheduling advantages offered by the Korean platform.
Politics wins.
It is a stark reminder that for smaller NATO nations, alliance architecture often overrides raw engineering data.
While Poland's massive procurement strategy is impressive in its speed, the logistics analyses in the reports point out a terrifying operational risk in their approach. To hit that 900 tank goal quickly, Poland didn't just buy the K2, they bought everything available.
They adopted a highly fractured fleet architecture. They are currently operating their legacy German-built Leopards. They are simultaneously taking delivery of hundreds of brand-new M1A2 Abrams from the United States, and they are standing up their massive K2 fleet from Korea.
Operating three entirely distinct, highly complex main battle tank platforms simultaneously sounds like the definition of a logistical nightmare.
It is a profound vulnerability. It requires maintaining three completely separate, incompatible stockpiles of spare parts. It requires establishing three entirely different training pipelines for mechanics and technicians.
You can't just swap a crew out.
Furthermore, the operational paradigms are completely different. A tank crew trained to operate the manual loading Abrams with its specific fire control interfaces cannot seamlessly transition into the auto-loading K2. If one fleet takes heavy casualties, you cannot easily cross-deck crews or cannibalize parts to keep the other fleets running.
It's too fragmented.
The lesson for Canada is clear. While rapid delivery is essential, selecting a single, sustainable platform architecture is critical for long-term endurance.
Implementing any of these solutions, the active protection systems, the digitized turrets, the massive logistical tails, requires an astronomical amount of capital. How does a nation actually finance this transformation, and who benefits economically from the expenditure? Let's delve into the Parliamentary Budget Officer report on defense spending.
The PBO report lays out financial projections that represent a historic shift in Canadian fiscal policy. The Department of National Defence has established a capital expenditure plan aiming to spend $322.9 billion over the next 20 years.
That number is almost difficult to conceptualize. $322.9 billion dedicated purely to capital acquisition.
And the spending curve is incredibly steep. The projections indicate that annual capital spending will peak at an unprecedented $25.7 billion in the 2030-2031 fiscal year.
That's a huge spike.
To contextualize this shift, this new plan represents a massive injection of $108 billion more than previous long-term defense spending outlines.
While the funding commitments are historic, the PBO report also dedicates significant space to outlining a chronic, systemic failure within the Canadian defense establishment. The reality is that allocating the budget in Parliament is a completely different process than actually writing the checks to manufacturers.
The D&D has a deeply entrenched, well-documented history of severely underspending its allocated capital budget. The PBO audit revealed that between the years 2017 and 2024, the department fell short of its planned capital spending by a staggering $18.5 billion.
If I am analyzing this from the perspective of a taxpayer or a frontline soldier, I find it incredibly difficult to reconcile how a military, which is openly declaring its equipment is obsolete and desperately requesting massive fleet replacements, somehow fails to spend $18.5 billion that was explicitly set aside for that exact purpose.
Where does the bottleneck occur? The bottleneck is the architecture of the Canadian procurement system itself, which is famously risk-averse and labyrinthine. Procurement is not controlled by a single entity. It requires consensus across the Department of National Defence, Public Services and Procurement Canada, and Innovation, Science and Economic Development Canada.
Too many hands on the steering wheel.
Precisely. This structural complexity leads to continuous schedule delays, constantly shifting project scope requirements, and agonizingly slow contract negotiations. The financial mechanism exacerbates this. Capital funding requires parliamentary approval through a mechanism known as Vote 5 of the estimates.
How does Vote 5 impact the actual purchasing timeline?
The funding approved in the estimates is strictly tied to the fiscal year, which ends on March 31st. If a tank manufacturer experiences a minor supply chain delay and cannot deliver the vehicles before that March 31st deadline, the Canadian government cannot legally issue the payment.
So the money just sits there.
No, that unspent money laxes. It doesn't sit in a bank account waiting for the delivery. It returns to the central fiscal framework. The DND then has to engage in complex bureaucratic fight to have that lapsed funding reprofiled and approved again for a future year.
That sounds exhausting.
The grave risk identified by the PBO is that as the capital budget aggressively expands to meet the 2030 modernization deadlines, the bureaucratic machinery simply lacks the processing bandwidth to spend the money fast enough.
When those massive contracts are successfully executed, the Canadian government enforces strict policies to ensure that capital doesn't simply disappear into foreign economies. The source documents extensively detail the Industrial and Technological Benefits Policy, or the ITB.
The ITB policy is the central pillar of Canadian defense economics. The premise is straightforward but highly impactful. For every single dollar the Canadian government awards to a prime contractor, whether domestic or international, for a major defense purchase, that company is legally obligated to generate a matching dollar of economic activity back within the Canadian economy.
A strict one-to-one financial offset.
Yes, they achieve this by sourcing physical components from local Canadian suppliers, investing heavily in Canadian university research and development programs, or directly supporting local small and medium-sized enterprises to build up the domestic industrial base.
To visualize how this macroeconomic policy functions on the factory floor, the Spotlight Stories document we reviewed provides compelling specific examples. Let's look at the current contract with General Dynamics Land Systems Canada, based in London, Ontario. They were awarded a contract worth up to $3 billion to manufacture 360 new combat support light armored vehicles.
A massive infusion of capital into the Ontario manufacturing sector.
But under the ITB obligations, General Dynamics cannot simply hoard that contract and manufacture every bolt in-house. They're required to distribute the economic impact. For example, they partnered directly with ProMetal Industries, a manufacturing firm located in Regina, Saskatchewan. Crucially, ProMetal is an Indigenous-owned enterprise, wholly owned by the Pasqua First Nation.
That is a perfect execution of the policy's intent.
ProMetal is manufacturing highly precise, specialized metal components for these new armored vehicles. Therefore, a multi-billion-dollar federal defense contract awarded in Ontario translates directly into long-term high-skill manufacturing jobs, technology transfer, and sustainable industrial capacity for an Indigenous-owned business in the prairies.
It creates a resilient, highly distributed domestic supply chain that can survive geopolitical shocks.
Another prime example from the sources is Rocan Machine and Tool Company, a smaller firm in Ontario that secured contracts to supply heavy metal fabrications for the same vehicle program, directly supporting specialized welding and machining jobs. But perhaps the most illustrative example of how defense spending offsets can generate unexpected, highly vital spin-offs involves Seaspan, one of Canada's massive shipbuilders. As part of their IPB reinvestment obligations, they provided critical funding to a very small Vancouver-based design business called Helgaware.
Helgaware operates outside the traditional defense sphere, correct?
Entirely outside of it. Helgaware designs heavy-duty safety coveralls, specifically engineered for women's physiology. Historically, female welders, mechanics, or shipbuilders have been forced to wear protective gear designed for male proportions.
Which is terrible.
Ill-fitting, baggy workwear around heavy industrial machinery isn't just uncomfortable. It is a severe safety hazard waiting to snag in a lathe or a press. By injecting defense offset funding into this small company, they were able to properly design and manufacture safe, necessary equipment, allowing Helgaware to rapidly expand their business across multiple non-defense industrial sectors.
If we extrapolate that mechanism to the global tank procurement market we analyzed earlier, the ITB policy perfectly explains why international industrial conglomerates are aggressively courting the Canadian government right now. Consider the Hanwha Group, the massive South Korean conglomerate that manufactures the K2 Black Panther. When they pitched their tank to Ottawa, they aren't just selling an armored vehicle, they're pitching the integration of an entire industrial ecosystem.
How broad is the scope of their pitch?
According to the business reports, Hanwha's strategy is comprehensive. To demonstrate their commitment to the ITB obligations, they are signing memorandums of understanding with the province of Alberta to cooperate heavily on energy sector innovations, specifically focusing on natural gas infrastructure and clean hydrogen development.
Oh, wow. Not just military stuff.
Furthermore, they are partnering with American naval design firms like Gibbs & Cox to potentially bid on Canada's looming $54 billion submarine replacement project.
So the underlying message from the defense contractors is, award us the multi-billion-dollar tank contract, and we will leverage our massive corporate empire to simultaneously invest in your domestic energy transition, upgrade your naval shipyards, and fund your academic research.
Exactly. Selecting a next-generation tank platform is far more complex than comparing the millimeter thickness of the composite armor or the horsepower output of the diesel engine. It is the formation of a multi-decade industrial marriage. The corporation that wins this contract will become deeply embedded in the fabric of the Canadian economy, directing massive investments into everything from localized steel production lines, potentially modernizing facilities like Algoma Steel, to funding advanced artificial intelligence and sensor research at Canadian universities.
So what does this all mean? Synthesizing the sheer volume of technical data, strategic doctrine, and economic policy we have examined today, what is the ultimate trajectory of this transformation?
The overarching trajectory is a frantic race against the geopolitical clock. The Canadian military establishment is attempting to completely jettison a 30-year legacy of optimized, light expeditionary peacekeeping.
The racing yacht is gone.
The racing yacht is gone. They recognize the existential threat of the lethality gap, and they are moving to commit hundreds of billions of dollars to forge massive, heavy, digitized maneuver divisions. They are attempting to procure next-generation armored vehicles that possess the raw thermodynamic engineering to survive the freezing, unforgiving reality of the Arctic, while simultaneously possessing the computational speed and active protection systems required to survive the highly transparent, drone-saturated battlefields of the 21st century.
It's a tall order.
And they must execute this flawless pivot while navigating a notoriously slow procurement bureaucracy and ensuring every dollar spent actively reinforces the domestic industrial base. It is an undertaking of staggering complexity.
As we look toward that future, specifically toward those next-generation vehicles wrapped in their active protection systems and deeply embedded within their electronic warfare kill webs, it feels as though the mechanical evolution of the tank is accelerating at an unprecedented rate. But I wonder if that acceleration is approaching a hard limit.
It is a critical line of inquiry, and it touches on perhaps the most profound vulnerability of future combat systems. We have spent this hour discussing the limits of physical hardware. The maximum weight a bridge can hold, the lowest temperature a battery can survive, the maximum speed a radar can track a drone. But as these vehicles become rolling, multi-domain data centers, the ultimate bottleneck in armored warfare is shifting away from the metallurgy of the armor or the ballistics of the gun. The absolute, unyielding limit of the next-generation tank will be the cognitive capacity of the human being sitting inside it.
Because the environment is simply becoming too complex to process.
Precisely. Imagine the interior of a future tank. You have a crew of 3 or 4 human beings attempting to navigate treacherous terrain, manually track targets, manage the power output of their electronic warfare jamming domes, monitor the intercept geometry of their active protection systems against swarm attacks, and process constant streams of digital targeting data from off-board drones and allied infantry.
All while under fire.
All while experiencing the terrifying, visceral, physical shock of being under sustained artillery fire. The central question for the 2050 battlefield is this: can the human brain neurologically process that sheer volume of lethal information fast enough to make survival decisions? Or will the velocity of warfare force us to remove the crew entirely, handing the autonomous control of 60 tons of lethal armor over to artificial intelligence simply to keep pace with the speed of combat?
That is a deeply unsettling yet inevitable question to consider as we watch these machines evolve. To everyone listening, thank you for joining us on this incredibly deep dive. As always, we appreciate you taking the time to unpack the dense hidden mechanics of the systems shaping our future, and we encourage you to keep questioning the rapidly shifting strategic landscape around you. We'll see you next time.